Yes, class. Good evening. I leave the class after. Okay, ma'am. Now just inform me before you are leaving. So, in the last class on Monday, we had started with ray optics. That is your chapter number. Okay, ma'am. So your ray optics was started, chapter number 9 from NCRT part 2 book, and we have already completed one topic, that is refractive index. So as I have told you, refraction was already a part of your syllabus. That we'll discuss it later after studying reflection, because reflection has been recently means it has been again introduced into your syllabus. So chances of reflection coming in your paper is much more. Now see, what phenomena occur if a light strikes a surface? For example, this is a surface. Now, if a ray of light is incident on this, this is what? This is the incident ray. There will be a perpendicular to your plane, which we refer to as the normal. Whenever the normal term is used, no, it is always used to denote 90 degrees. Normally, electric field lines are with number of field lines that are passing normally per unit area, that we called as electric flux. Normally means what? 90 degree. So we draw a perpendicular. Now phenomena that are possible. See, one phenomena that is possible is that this ray of light, this can reflect back, which we say this is reflected ray, and the phenomena that has occurred is reflection, bouncing back of light. The light has bounced back. Now this is incorrect, which I have drawn, because this gap of angle is not correct. Both the angles should be same. Then the other phenomena that occurs is refraction. This is the refraction that occurs, and this is the refracted ray. And one more thing that can occur, which obviously you will not be able to observe, is within some portion of the incident light that is striking the surface. It may happen that in the second medium, the ray of light is absorbed. So we say that is absorption. So obviously absorption will not be visible to you. Here, some portion of the light has been absorbed. So absorption of light also can also occur. Absorption of light. So phenomena that are occurring: reflection of light ray, refraction of light ray, and reflection of absorption of light. Remaining third part of the light energy which is left, that gets absorbed. One part is reflected, one part is refracted. Absorption you do not study. Refraction we'll see later on. Reflection we'll start with this reflection. Now, as I was saying that this is incorrect, why is this diagram that I have drawn is incorrect? See, you can correct it whenever you are drawing. You will see by the laws of reflection. There are certain laws of reflection which have to be obeyed whenever you are drawing a ray diagram or whenever the phenomena of reflection occurs in nature. Now, two laws you have to remember. First law is very important, which I was referring. That first law says that angle of incidence is equal to angle of reflection. Angle of incidence is equal to the angle of reflection. It means angle of incidence is what? Angle of incidence is the angle that the incident ray makes with the normal. This is your incident ray, this is your normal. This is the angle of incidence. If this angle is, let's say, 30 degree, for example. So this is your reflected ray. Angle of reflection is angle that the reflected ray makes with the normal. This will also be 30 degrees. So angle of incidence is what? Angle made between incident ray and the normal. And this is angle between reflected ray and the norm. But whenever you are asked in the exam to mention about laws of reflection, just mention angle. First mention angle I is the angle made between incident ray and normal. Angle of reflection is this. Or if it's just for 2 marks, directly write the statement angle of incidence is equal to the angle of reflection. Not consider this as the angle of incidence. This is 90 degree minus angle of incidence. This angle is different. This angle is different. This is your angle of incidence and this is your angle of reflection. And once a light is incident on a surface, on a smooth shiny surface, it gets the reflection as it is. It reflects itself back. This is the first law. Second law of reflection says what? That all these three rays which I am referring to, the incident ray, the reflected ray, the normal, they all lie exactly in the same plane. It means, let me write down the statement first. The reflected ray the incident ray, and the normal. So the reflected ray, the incident ray, and the normal all lie in the same. This means this is one surface, this is another surface. This is the normal to this surface. If the ray of light is incident on this surface, it will not happen that the light ray is getting reflected on this surface. This is not possible. And also, one more thing that is meant by the second point is incident ray. This light ray is incident on the xy plane. So if this is incident on the xy plane, it will not happen that the reflected ray, which is the ray that is getting reflected, this will occur in the YZ plane. That it means it will come outwards to get reflected. If this is your axis, no, X, Y, Z. If this is incident, it will not come over here. It will get reflected in the same plane. This is not possible. This presents. Fine. So these are the two laws of reflection. First law, both the angle of incidence is equal to angle of reflection, and all these three rays lie in the same plane. 2 dimensions, so 2 dimensions. XY plane, so XY plane. It's not X1 and XY, other in YZ. Note it down till here. Then we'll start with mirrors. Reflection. In reflection, you see in reflection you have mirrors. And in refraction, you have lens. We'll start with mirrors. Okay, Sana. Let's start with spherical mirrors now. Spherical mirrors. Now, what are actually spherical mirrors? A complete reflecting surface will be there. Fine. This is a complete, let me draw it slightly towards the edge. Now this is a reflecting surface. Fine. I have taken a part of this. I have cut this, and now I have taken a part of this part which I have cut. Fine. Now I have now applied silver polishing on this surface, on this side. This side I have painted it with silver. Now this type of mirrors that we get, where bulge is silvered and the reflection occurs in this plane. Reflection occurs in this plane. I'll erase this right now. And reflection takes place from inner surface. Reflection takes place from inner hollow surface. This type of mirror is known as concave mirror. Now, instead of silvering this side, I had this side. Now, if I had silvered means polished, just applying polish. If this side I have silvered, now reflection will occur from this side. This mirror is known as a convex mirror. And here the reflection occurs from bulged surface. And inner is polished. Inner surface is polished or silver. These are the two. So mirror is actually what? You have a full reflecting surface with you. Out of that full reflecting surface, you have taken a part of it. That is known. That's why you get this curve also. We call this as part of a spherical mirror. So one is concave, one other is convex. This depends on the polish that you're applying on the mirror. If you're applying the polish on the outer side and the whole reflection is occurring from the inner hollow side, that is your concave mirror. If this side has been silvered and the reflection is occurring from this point, this bulged part, then we say this is a convex mirror. Fine. Now let's understand certain properties of it. Not properties exactly, certain points we have to be aware of before we begin with it. I have taken a curved surface over here. This is a whole complete reflecting surface, which forms a hollow sphere. This is a complete reflecting surface. Fine. Now, if I have just polished this part, I have have just polished this part only I have polished. So this is acting as a mirror. This part is acting now as a mirror for me. But there are certain terms that you have to understand before you move on to the details. See, this whole sphere, the reflecting sphere will be having its center. We call the center as center of curvature. Center of curvature. Then if this is what first point is center of curvature. Center of curvature is what? It's the center of the sphere from which the mirror is a part of. Fine. This is the center of the sphere. Center of sphere. Then you have one term known as pole. Before we move on to pole, let's study principal axis first. See, this is a line that passes straight away from the mirror, or you can say it is a straight line that passes through the middle point of the sphere. This we call as the principal axis. This is known as the principal axis. So it's basically the diameter. It passes through the center of curvature of the mirror. So this is known as principal. This is known as principal axis. The point that coincides with the mirror and the principal of axis, this point, this is known as pole. Pole of the mirror. Pole will be used a lot when we will be taking references and drawing ray diagrams. Fine, pole will be used a lot. Got it? So pole, center of curvature. Then this is the radius of the sphere. Hollow sphere. See, we'll be focusing on this part only. But when we'll be using the terms, you have to understand the meaning of it. This is the radius of curvature. Denoted by capital R. Radius of curvature means the radius of this complete sphere. That will be this much distance only. This is the radius of curvature. So pole, middle point of spherical mirror, center of curvature, line, the center of the hollow sphere, radius of curvature, arc, or you can say radius of the sphere, principal axis, a line passing through the center of curvature and the pole. And you have linear aperture. Linear aperture means, let me name this point. This is A, this is B. So this is the aperture through which the light will enter. This part will be removed. This part is the mirror only, no? So this AB, this is known as the aperture, linear aperture. This AB, the straight line AB is known as linear aperture. Fine. Then you have angular aperture as well. One was linear aperture. Now, angular aperture means the angle that is subtended at the center. This whole part that it subtends the boundary of the spherical mirror. This was the linear aperture. This part of the mirror. C class. This part of the mirror. This is known as this part. This is known as the angular aperture. This is known as the angular aperture. Find this part. This is your linear aperture. That is your, yes, I'll repeat. See, this part. This is also an aperture, straight line. If you just notice this straight line, this part is also acting as an aperture. if you look over here, this part, AB, if you go straight away, draw a line over here. This is also acting as an aperture where light rays can enter. Fine. Now what will happen? If I talk about where exactly the light rays will fall, they'll fall on this curved part as well. So we call this as angular aperture. Linear aperture, this is your curved surface, no? This part, this aperture from where the light will enter, this is known as linear aperture. And this part of the sphere, this part, from where the light rays will bend and angulate themselves, this is known as angular aperture. Clear? This part is clear? Okay. So radius of curvature, principal axis, pole, center of curvature, angular aperture, linear axis, and principal focus is there. See, where a point will be present, this is known as focus, where all the light rays will tend to emerge at a point. All the light rays will meet at this point. That we call as the focus. This is known as the principal focus. We commonly say it as the focus. This is what this is known as the principal focus. This point, this that you're getting, this force, F, focal. This is principal focal, or normally we say it as focal. Focal term we use, focus we use. This is the focus. Here what will happen? Light rays will converge or diverge. Light rays here converge or diverge depending on the type of mirror. So we have not studied in detail about convex and concave mirror. We have just seen a brief overview of what are those mirrors. First, let us understand the terminologies, then you will be able to see the difference between concave and convex mirror. Fine, so this is a principal focus. Now, for the distance that is there from the pole and the focus, this distance, that is distance between pole and focus, this is known as focal length. Focal length is what? Focal length, if this point is P, so this focal length is PF. Distance between the pole and the focus, the point at which light rays are converging. This is focus. Don't confuse with this point or center of curvature. Center of curvature is different. Fine. So these are all the terms that you should be aware of. And this plane, the vertical plane that is passing through the principal focus and the principal axis, that you call, this plane you call as the focal plane. So I'm repeating these points. Just listen these points once again. Your part of the mirror that was cut from the whole sphere, this is known as a mirror. If you paint the surface from inside, that gives you convex mirror. If you paint the surface from outside, you polish it so that no reflection occurs, then that is known as what? That is known as a concave mirror. Fine. Just a second. Now see, the center or the exact center of the sphere, this is known as center of curvature. Then the radius of the sphere is known as radius of curvature. The diameter or the parallel line that joins the two diametrically opposite points in the sphere, this is known as the principal axis. And the point which intersects the principal axis with the curved surface of the mirror, that is known as the pole. All the rays will appear to meet at a point, or they will try to diverge it from the point depending on the nature of mirror. That point is known as the focal. The parallel rays of light will meet at this focus. These rays diagram we'll see. Length of the focus, or you can see the distance between pole and the focus, is known as focal length. AB, this is known as a linear aperture, and this is known as an angular aperture. And this focus, principal axis, center of curvature, these are occurring in the same plane, which is known as the focal plane. Got it? Yes or no? Others? Khalid, Maimuna, Salman?
Yes, teacher, understood.
Yes, ma'am.
Okay. So note it down. Then we'll see the sign conventions that are there. Just note this down. Yes, class. Can we start?
Yes, ma'am.
All right. So sign convention, let's start with the Cartesian sign convention. New Cartesian sign convention. See, certain sign conventions we have to choose whenever we draw, especially for ray diagrams. This is important. Let me draw the principal axis. This is the principal axis. This is the mirror. Fine, this is your mirror. Let's write it as a concave mirror just for reference. Whenever these dotted lines will be there, no, at the back side of the mirror, that will show that the polishing has occurred, because every time you cannot color it and draw it. So these lines, these small lines will depict you the silvering of the mirror. First, all the ray diagrams are drawn with the incident light that is traveling from left to the right. This is the direction of incident ray. This is how you will draw the incident ray, and this becomes your reference point. So first point is what? All ray diagrams are drawn with the incident light traveling from left to right. Traveling from left to right, and all the distances are measured from this pole. So second point is that all the distances are measured from the pole. Fine. Now, sign convention means one side has to be taken positive, other side has to be taken negative. Remember, class, you must have done it in your relative velocity, especially that one side is taken as positive, other side is taken as negative. So that time, when do we do that? See, one side you cannot take it as positive, like right side you cannot take it as positive, or left side. We go with the incident ray. All the things, all the rays of light that are on all the distances that are measured in this direction, in the direction of incident ray, that we take it as positive. Now, whatever will be the direction of incident ray, that we'll take it as positive. So third point is what? All the distances are measured from the pole. Third point will be all distances measured from or measured in the direction. That will be better. Measured in the direction of incident light. This is said to be positive. For example, if you are calculating a distance in this manner, from the left to the right in the direction of incident ray, you will write that distance as positive, like plus 5 centimeter. And this, if you're measuring a distance like this from the pole, let's say towards this point or any point, let's say from the pole to this point, the image is formed, you're measuring this. So this distance, now this will become negative. Sign convention, just remember the sign convention for now. Rest of the things you will understand it when you will be doing the mirrors when you'll be drawing the ray diagrams. And opposite to it are said to be negative, measured in opposite direction of incident light are said to be negative. So one will be positive and second is negative. Fine. See, distances that are measured like this. You can look here for better understanding. See, if this is the direction that you take for the distance, so this distance, this will be positive. If you are choosing, you are moving away, so this distance will be negative. Fine. Now regarding the height of the object. If the object is kept above the principal axis, then the height is written as positive. This height is positive. And if it's below, so this height is negative. So all the height above the principal axis, you will write it as positive. For example, an object is kept over here. So height of the object will be positive. And if the object's image is formed downwards, so you will write the height of the image as negative. Obviously, you cannot keep an object below the principal axis. So always the object's height will be written as positive. So heights measured upwards. Heights measured upwards and perpendicular to the principal axis. This is taken as positive, and opposite measured downwards and perpendicular to the principal axis is said to be negative. Fine. So upwards positive, downwards negative, towards the direction of incident ray positive, against the direction of incident ray negative. This is what is the sign convention, and focal length and radius of curvature are negative for a concave mirror and positive for a convex mirror. That we'll see later on. Before we move on to anything, first write down this because rest of the derivations use this. And any doubts in here, please let me know. I'll repeat that. Just let me know the point number. I'll repeat the point number.
Now, for sure, you won't come tomorrow school.
See, let's see the rules that are necessary for drawing a ray diagram. 4 rules are there that will be used. And those rules remain the same for both convex and concave mirrors. We'll see the formation of images by concave mirror and convex mirror separately. For convex mirror, you just have one case. That is very easy. 1 or 2 cases you have for convex. Concave mirrors we'll be dealing in detail, and opposite will occur in refraction. Convex lens will be dealt in detail. So before we start with the formation of images by the concave mirror, we'll see the rules for drawing images formed by the spherical mirror. First point is, see, if a parallel ray comes, this is the center of curvature, this is the focus. This will pass through the focus. This is the first point. Second point, reverse of this. Even this is valid for both convex also. Even if a parallel ray is coming, this will be the focus of it. This is the center of curvature. Convex we'll see later. Let's see it here. Reverse will occur if a light ray that is passing through the focus, it will move parallel. What had happened here? Parallel ray came, it passed through the focus. This is your mirror, this is focus, this is center of curvature. If a light ray is moving from the focus, this will move parallel like this. Reverse will occur. Even if it's a concave mirror, convex mirror. Concave, this will happen for convex. See, this is focus, this is center of curvature. If the light ray is passing through the focus, this will move parallel. Reverse, just the reverse of the first point. This is the second point. Third point says what? If a light ray passes from the center of curvature, it will retrace itself. This is the center of curvature, this is the force. If this is coming, it will, after striking the mirror, it will reflect back. So after striking the mirror means this. It will reflect back as it is and retraces its pathway. But it has to pass from the center of curvature. Last point. See, for the ray incident at any angle at the pole, reflected ray follows the simple laws of reflection. Okay, this is valid for convex also. This is focus, this is center of curvature, light ray is coming. Light rays will come till here only. This is the extension. Remember we did on Monday's class, virtual image and virtual object that appear to me. This is what dotted lines are showing. So this will also retrace its path. Last point is if it strikes on the pole. This is the last point, fourth point. Let me draw the concave mirror. This is again, I'm repeating, this is showing you the silver polishing. Now what will happen? A ray of light is incident at the pole at certain angle, theta. So it will follow laws of reflection, means this will also be theta and it will get reflected like this. This follows laws of reflection. It means angle of incidence is equal to angle of reflection. Follows the laws of reflection for any angle at pole. Fine. So these are the 4 laws of reflection. Do one thing, class. Note it down till here, these 4 points. Then we'll see for ray images for a concave mirror. Just note it down. Khalid, were you asking any question? Khalid.
No, teacher.
Okay.
Ma'am, could you show the second one again? Okay.
See, formation of images by concave mirror. So majorly you have four cases between the center of curvature and focal. Beyond C you have exactly at center of curvature. Then between F and C, then you have between F and P, means between the focus and the pole. See, if it's beyond C, no. This is the mirror. This is center of curvature. This is the focus. This is the pole. These three will be your reference points that you will take. Now the object is kept where? See, object is kept anywhere beyond C. Fine, let's say this is AO and this is your object. What will happen to the rays? From the object, firstly, the rays will be parallel. If you have scale, please try to draw it with scale. Otherwise, your ray diagrams will not become proper. In your exam also, please do not draw it free-handedly. So if it's parallel, it will definitely pass from the focus. First rule, satisfied? Light rays are moving parallel to the principal axis, so it will pass from the focus. Second ray of light will be from where? Second ray of light will be from the center of curvature. What will happen? If a light ray passes from the center of curvature, it retraces its path. I've extended the mirror. You also, in your diagrams, ensure that this is getting reflected. Otherwise, they won't use. See, here an image is formed. OA. Are you able to notice that this is now an inverted image that has been formed? So at this point, what is happening? At this point, this is your image is formed between C and F. It's a real image. As you can see, this is actually being present. Here, the rays of light are actually meeting. What did we study in the last class? That if the rays actually meet, the image is real. Image is inverted also. And one more point, that it is smaller also. It is smaller than the object. This is very important. These points also come that I'm mentioning. Fine? Any doubts in here? Clear? This first part.
Yes, ma'am, clear.
All right, good. Second part. Now let's shift our object a bit. From here, let's keep the object let's keep it exactly at center of curvature. Firstly, let's keep it exactly at the center of curvature. At C. This is the center of curvature. This is the focus. This is the pole of it. Now, object, I have kept the object exactly at this. Fine. This is OA object. So this light ray, this will go, it will be reflected by the mirror and it will pass through the focus of it. Fine, this passes through the focus of it. What happens to the second mirror? See, the second ray of light, it will pass through the focus. because center of curvature is not now available. See, if this passes through the focus, when a ray of light passes through the focus, what have we studied? That it becomes parallel. So this will also become parallel now. You can draw it with the help of scale. It will be better in your notebooks that you will draw. Here you are obtaining an image. This is O dash A dash. Let me write it as dash. Otherwise, the difference between the images will not be clear. O dash A dash. This is the image. So at C, what is happening? See, this is not so clear in my diagram. I hope in your notebook, when you draw it with scale properly, because these are important. And at times also, you may also face the same thing when you draw it in your notebooks. It can happen that you're not getting it exactly. So make sure. What happens to the image? Make sure what happens to the image. Image is formed where? Exactly at C. So object was also at C. Image is also at C. Do you see this? Both are at this same point. Again, since it is formed because of the presence of actual lines and the conversion and meeting of the actual lines, it's a real image. Inverted, you can notice. And see, there is no difference between the height of the objects. Both are same. So, same size. If a theory question comes, at what point do you see that the image size and the object size is same? It's at the center of curvature. Fine. Let's shift our image. Let's shift our object a little more. A little more. It was right now. It was shifted towards C. Now let's keep it between focal and center of curvature. This is the focus, this is the center of curvature, this is the pole. Now I am saying let's keep our object between C and F, anywhere between C and F. So this is what? AO. Now the rays of light that will come. So first ray of light will come. This will be parallel to the principal axis, therefore it will pass through the focus. Fine, this will pass through the focus. What about the second ray? Second ray, we have studied that the second ray passes through the center of curvature. Second ray passes through the, or instead of center of curvature, no, let's write it in terms of focal only. So pass this ray from the focus, because center of curvature you do not have mirror. Pass it from the focus. If it passes from the focus, then this will become parallel. And here at this point you are obtaining an image when you draw. This point we are obtaining the image. This is O dash, A dash. Fine. So what are the conclusions that we can draw from this ray diagram? Firstly, that this is formed beyond the center of curvature, this image. Remember, this is beyond C. Now, anywhere this can be formed depending on the position of the object between C and F. So firstly, image is formed beyond center of curvature. Second thing, real and inverted remain the same here as well, real and inverted. And lastly, you can see this is larger than the object. O dash, A dash, this image is greater than OA. So this is larger than the object. Last ray diagram for the concave mirror. Let's shift it a bit more between F and P. Let's keep it between F and P because rest of the possible things we have done it. So fourth, between focal and the pole. Focus and the pole, we are keeping it. This is the focus, this is the center of curvature, this is the pole. OA object has been kept over here. First law will follow, ray will be parallel. See, this is parallel. And it will pass through the focus. This will pass through the focus. What happens to second ray of light? It passes through the center of curvature. And it gets reflected back. Now see what will happen to the light rays. They are not meeting anywhere. But if I produce and extend this, these rays are appearing to meet at this point. So this is my image O dash A dash. So what are the conclusions that I can draw from here? This is the image O dash A dash. See, regarding the conclusions about the image. First point, where is the image formed? It is formed behind the mirror. Image is formed behind the mirror. Second point, it is not inverted this time. OA, so O dash A dash. This is not inverted this time. This is erect. And it's not a real image. See, the light rays are not actually meeting. They're appearing to meet at a point. So this is virtual as well. And regarding the size, so it is larger than the object. Got it? These are the points for concave mirror. For convex mirror, you just have one single case. Formation of image by convex mirror. This is your convex mirror. Object is kept OA. This is kept where any position between infinity and pole. Any position behind the mirror. What will happen? Parallel rays will come. This is the focus. This is the center of curvature. They'll appear to pass through the focus. Fine. And second ray will come from through the center of curvature. So an image will be formed here. So regarding the image is formed where? It is formed behind the mirror. It's virtual because light rays are not actually meeting. It's erect. As you can see, this is exactly O dash, A dash. And lastly, this is smaller than the object. And not only by the ray diagrams, apart from the ray diagrams also, you all should remember all these points. If these are asked, these can be asked separately in your theory questions. Fine, note it down. Any doubts, ask me, I'll repeat the image. From here, you have to note it down. And text me done when you are done with the writing part.
Ma'am, we don't have to learn like all the rules. Like there is one with infinity also where the image is infinity. Don't remember
Formed
like
at the
that is not
infinity, the
necessary.
ray will form at the focus.
Okay.
That will be from the rules only, no? So any question will be given to you. If it's at infinity, so we have already studied in the rules that if the lines are from infinity, then you have what? You have the rays forming at the focus. So that also, yes, you can add it also by yourself, but that is actually included in the rules. That's why I didn't do it. You can do it separately as well. On Monday, you will be having a test of EM waves, electromagnetic waves, the chapter that we have ended before ray optics. So revise that table and the theoretical portion as well as the numericals also. Others have also done apart from Sana and Sumaira.